So force equals to P omega. That is, force is directly proportional to linear momentum and its angular velocity. Force is directly proportional to momentum and its angular velocity. So F equals to P omega. So where P we know what is P? M into
V.
P equals to M into V. Okay. So let's write some points to remember about centripetal force. Magnitude of centripetal force is F equals to mv square by r. It is derived from this one. We can get from this value. Second point to remember, F is directed towards center of circle. Next point to remember, M, V, R remains constant. So F remains constant because MVR is constant. In force, what we have MVR. So therefore, direction at different point but always towards center. Always towards center. So from the diagram which we drew before, F is perpendicular to V. So let's write the point also. F is perpendicular to velocity. Therefore, it is perpendicular to displacement. Therefore, F is perpendicular to displacement. So, work done equals to 0 because force is perpendicular to displacement. That means 90 degree. As we know, W equals to Fs cos theta. Cos theta is 90 degree. That means work done is 0. Are you able to relate this? Next point to remember. So centripetal force, wait, yeah. Centripetal force does not change speed of part. We are adding same thing here, but different manner. Particle moving along circular path. So Ke remains constant. And from here we saw A is perpendicular to velocity. Acceleration is perpendicular to velocity. Perpendicular to velocity. So can someone tell me some example of centripetal force? Yes, let's start with Pravalika. Yeah. Give an example of centripetal force. Yeah. Oh.
Pande. Sir, ball spin.
Ball spin. Okay. Next, the area. Give me one example of centripetal force. You're there. Okay, Neha. No idea? Any example of centripetal force? No. Ramcharan?
So turning a car.
Turning a car. Okay, we just send in a circular path. Like, okay. Make it like, yeah, fine. Sainyati? No example? Vishwanath? Okay. Yes, Adhyasya? No examples? What is this? Don't know any example? So many examples. Earth moving around sun. Electron moving around nucleus. So many examples. A ball tied here. If you tie a ball here, it will just play with that. That is what centripetal force. Yeah, anyone, he gave example. Moving of car or turning of car. Okay, let's do numerical then. So uniform speed of 12 meters per second is given. So we have mass of bob, length of string, uniform speed. They are asking what? What is the centripetal force acting on the bob? If the bob is 5 meters per second. Calculate tension in a string also. Okay, so what you will do here? Come on, try this question. Come on, try this question. So what you will do here? Radius is given. Is it? Mass is given. Bob given. Centripetal force F equals to mv square by r. So here V will be what? $12 or 5, which we will take? Come on, tell me. Joining and leaving, why? Internet issue. Internet problem. Okay. Yes, what's the answer? Have you solved? Or you're doing it? Are you all there or not there? Are you doing it? Shall I solve? What do you want? Okay, let me solve then. 0.6. Okay, this thing is given, right? Okay, mass of bob is given. Then length of a string, that is, we can take as a radius r, 1 meter. Then speed is given 12 meter per second. So let's find first F equals to m v square by r.
By
So
R.
yes. So you got the answer? Anybody?
86.4.
86.4. Okay. Twelve are 144 and into 0.6. Yes. So with decimals, yes, 864. Point Newton. Correct. Now, second part, what they're saying, tension in a string. Tension means it is a force.
In newtons.
Yeah, exactly. Same way, mv squared by r. So 0.6 into 5 into 5, then 1. 25 into 6. 25 6 are 150. 150 Newton, 15 Newton. Is it clear to everyone? Easy? You tried or not? Okay. What about others? You tried?
Yes, sir.
Yes, sir.
Okay. You got the answer same? What about others? Jafar? Okay. Maybe those who joined it just now, we were just discussing about this. Important points for, yeah, centripetal force. We started from here. Okay, let me write one more question. Let's solve one more. You try that. A pilot of mass 70 kg in a jet aircraft moves in a vertical circle while executing the loop at constant of 200 meter per second. If the at the top of the loop. At the bottom of the loop. Okay. Now what they're trying to say, can someone explain? Doesn't matter right or wrong. What you understood from this? Yes, anyone? A pilot of mass 70 kg in jet aircraft moves in a vertical circle while executing the loop-the-loop at a constant speed of 200 meters per second. If the radius of circle is 2.5. What is the force exerted by the seat on the pilot at top of the loop and bottom of the loop? Okay, they're saying at the top of the loop. So that is this one, point A. At bottom of the loop, that is point B. So let's take this as a seed. And this one as a seed at the bottom of the loop. So what are the force acting here? First one, as usual, mg. And this is the top, that means and normal force also here. Now in this case, normal force is perpendicular to mg. Okay, anything else left? No. Let's write given terms. Speed is 200 meters per
200
second.
meters per second.
Exactly. Now, what else is given?
Mass.
Mass of pilot.
Pilot.
And what is this 2.5 then?
Radius.
Radius of the circle. So let's convert this also. In meters, it will be in meters, it will be 10 to power 3. Now let's start with the point A, that is at top of loop. So at top of loop, what loop? At top of loop, or we can say at the top of the loop. So if this is the position, then what is the position of pilot then? Imagine this one. See, when we are talking about top of the loop, we started from here, we are rotating here, and if you have been in that, what do you call? Roller coaster. What is it like? You will sit here and it will just, I don't know name.
Ferris wheel.
Yeah, giant wheel, right? That's what you said. I think so.
Yes.
Right? Yeah. So in that, when you're sitting here, if this is like that portion, this one is at rolling. Fine. But if this is a fixed position, if it is fixed, not like rolling, if we don't have ball bearing there or any bearing there, if it is fixed like a wall and it will rotate like this, it will at this position, where you're facing? Where is your face right now? Here it is, you're facing on this direction. You're sitting here. You're sitting here. Now, when it reached that point A, when this point B reached to point A, when object from here, it reached at point A. So what will be position of yours? How will you, which direction you will be facing? Upward or downward or left or right somewhere? Where will be facing? Are you able to understand what I'm trying to say? See, at bottom, at point B, you're sitting like this. And at point A, what will be your position? Which side you will be facing? Nobody understood what I'm saying? Okay, shall I show you giant wheel? Are they? No, not this one. Okay, let it be. Okay, let it be. I will answer this question then. See, let's go with the question itself. A pilot was sitting here and it is revolving like this. Then at this point A, the pilot position will be downward. He will be facing downward. So what will say? Upside down. So pilot will be facing downward. So it will be upside down. Can you imagine what I'm saying?
Yes, sir.
So pilot will be facing upside down. So his face will be downward. That's why we wrote here normal as downward. If you see here, normal is downward. See, here normal is upward because he's facing upward. He's facing like this. Here he is facing like this. Upside down, inverted. Okay. Then let's go with the question now. At this position, centripetal force will be equals to mv square by r as usual. So here we have n1 plus mg. In short, centripetal force is equals to n1 plus mg. We took here n1 and n2 because two n's we have. So centripetal force equals to mv square. Okay, so we need to find here n1. Why they are asking on the top of the loop, force exerted by the sheet on the pilot at top of the loop. So n equals to mv square by r minus, this will go that side, it will become mg minus, right? Okay. So do we have m? Yes. We have v? Yes. What else we have? R also we have. Come on, finish it. G we know, 9.8 as usual. What was M, by the way? I forgot. It is 200, yeah? No, 70.
70.
Into V is 200, no? Okay. 200 into 200 divided by R, I think so, 2.5 into 10 to power 3.
10 to the power 3.
Okay, 10 to the power 3, right? Okay. Minus M is 70 into 9. Let's subtract this. You will get the answer. Finish. That's it. Come on. For this calculation, I'll give you only 10 seconds. Yes, 5, 4, 3, 2, 1. Come on. Who got the answer? Not possible to do in 10 seconds? Yeah, not possible to do in 10 seconds? Is it or isn't? Okay, 10 seconds over, 1 minute also over, I think so. Yes, guys, what's the answer? Devanshika? Dhairya? Jafar? Neha? Pravalika? Ramcharan? Sainiyati? Shruti? Vishwanath? Adyasha? Come on, this many people. You didn't got an answer. Okay, you feel shy or you feel wrong answer, then you can send in a chat box.
Sir, 126.
It's 126.
Yes,
Yes,
sir.
sir.
126.
Yes, sir.
Okay, but here answer shows something else. 400. Let me solve then. Okay. Then 2.5. It is, if I said 25, 140, 104, 42, 50, 7. Five, 60. Oh, I'm getting negative answer. Is it negative?
Yes, sir. I'm getting
sir.
actually minus 126.
Yes, sir. Minus 126.
Oh, wait, I forgot this too. Okay. Now it is not negative.
Yes, sir.
Yes. Into 2, 686. It will be around 500 means 1000, 120 minus 686. It is 14, 20, 34, 434. 430. Yeah, I didn't took decimals now. Okay. Are we getting decimals? Let me use calculator. 70 into 200 into 200.
Sir, you won't get decimals, sir.
Huh. Then my book says decimals.
Sir, 434 only, sir.
It's 434 only, na?
Yes, sir. We
Yes, sir.
forgot to multiply that two.
Yeah, it's exact answer. That means book answer is wrong. Let it be. Doesn't matter. We need only question. We don't need answer. Okay. So am I recording? Yeah. Okay. So have everyone got the same?
Yes, sir.
Yes, sir.
Fine. Okay. Let's go with, oh, no, we didn't finish, no? Oh, this first part only. Yeah. At the bottom of the loop, yes. At bottom of the loop. Same thing you do, just subtract. N2 minus mg. That's it. Come on, get me answer. At B, what is B at? Bottom. So centripetal force equals to mv squared by r, which is equals to n2 minus mg. Because they're opposite. So n2 equals to mv squared by r plus mg. So it will be same, just we will add. So it will be 6, 8, 10, 7, 8. So 1, 8, 0, 6. I guess so, right? Am I correct? Check your calculation. I just calculated orally. I might be wrong. Is it 1806? I guess so. What's your answer?
Sir, 1806.
It's correct, right?
Yes, sir.
Okay. What about others?
Yes, sir.
Okay. Some few people are there. Devanshika, Dhairya. Are you there? If you can't speak, like if there is problem inside or you have some noise there, so at least you can type the answer. You can type your answer so that at least I can understand, okay, yeah, you're doing. You can type in the chat box so I can understand, yeah, you're doing it. Yeah, obviously you're at home, so it will be some problem sometimes. So you can type in chat box if you can't answer. But I want everyone to participate by any means. Either unmute yourself or type in chat box, whichever possible. Okay, then let's go with next topic, that is centrifugal force. These two are most important topics, centrifugal and centripetal. Other name is fictitious force. Fictitious force. So what is this force? A force which does not really act on a body, but appears due to acceleration of frame. Is called pseudo force or non-inertial force or fictitious force. Now, if I give you an example, when we are sitting in a bus and that bus is moving around that hill, any mountain. Let's take example of Tirupati mountain. So let me draw this. So how bus will move? It will be they will climb like this, right? So when they're turning, actually we are not exerting any force. This bus is exerting, okay, fine. But we will also rotate with him on the opposite direction. Okay. It is not acting on the force, it is not acting on it because we are sitting inside the bus. Force is not acting on us. Actually, because the bus is moving, so force is acting on bus. So due to that, we are also experiencing some rotation or some opposite direction force. Or that force is fictitious force or centrifugal force. In short, like if I give you some more example, actually see, when it is happening because of this force existing when we just now I drew in that reference frame. What was the reference frame? That mountain. So it was rotating like that. And it is, we are inside that bus and bus is in contact with the road. And road is also in circular path. So bus is moving, we are inside the bus. So we are also moving with bus in any whatever direction. So we don't have any direct contact with road or any other force, but we are in direct contact. We are in indirect contact. Okay. So are you able to understand what I'm saying? You understood what is centrifugal force?
Yes, sir.
Okay. Very good. Okay. So let's consider something And let's anyhow the formulas will be same. Okay, mv squared by r, same thing. It's not a big deal here. But force which is opposite to this one, centrifugal and centripetal, they both are there. The force, both force are there. So let us directly start with some reference frame and all that. Examples of motion. I have here a very good example. Let's see. Let me show you some example. Then let me write centrifugal force. CFF. So first example I can see here, that is telescopic mirror. Oh, let's start with some drawing machine. Yeah, that is good. Centrifugal drawing machine. Okay, so let me first write the points. We have some discussion on that. Wet clothes are kept in a cylindrical vessel with perforated wall. With perforated wall. This vessel is made to rotate fast. Now, what happens here? Due to centrifugal force, water is forced out through the holes when clothes are dry. So can you give a small explanation what is happening? Can someone give me a small explanation? Just one point. Yes, anyone? Who is volunteering? Anyone? No? I have to point out. Oh, skipped. Yes, Devanshika. I thought you can send your answer there. Okay, Neha, yeah. Can you give one small explanation for that? Okay, Pramalika. No?
Sir,
Yeah.
explanation about the points or
Yeah. Just explain. Just give me explanation about this point. Any just small explanation. Doesn't matter.
sir about the second point or first point? Sir,
Wet clothes are kept in a cylindrical vessel with the perforated cause. This vessel is made to rotate rapidly. Due to centrifugal force, water is forced
water is forced out through the holes and clothes are dry.
holes and clothes are dried.
Right.
Okay, fine. See, even like what is happening, and there is a wall, there'll be hole in that. Okay, so in that, so like clothes are rotated like this in cylindrical manner, but very fast, like rapidly. The speed is like so high. Okay, so that in the water inside that, it will just hit that, it will move outside. Again, it will hit that, again move outside. From the cloth, this water will move outside. Again, one more, this water will move outside. One by one, it will keep on moving outside. So that's what they are saying, right? Due to centrifugal force, water is forced from the clothes to move outside from the cloth and move out of the holes. Then clothes are dried. That's it. Very simple. Okay. Do you have any class or shall I continue for 5 minutes? Do you have any class after this?
No, sir.
Don't have, right? Okay, so let me just finish this one more example.
Yes, sir.
Okay. Actually, I want to show this device. Let me just show you. Yeah. See, this is also similar to that. So can you see this screen? Because I've shared my
Yes,
whole
sir.
screen. Yeah. In short, this all are rotating device. See this? There's a motor inside. Oh, there's not one node, right? This is a rotating device. If you see here, motor in center. Okay, let's come back here. That is centrifuge. The device used for separating light particles from heavier ones. Okay. Now you tell me how it will be happening. Let me show you that photo again. Okay, can you explain how it will be happening here? Yes, let me ask this Shruti. Yes, Shruti. Just now we saw centrifuge is what? A device used for separating light from the heavier. So what will happen here?
It is made to spin rapidly when the machine is on, and then
So light particle or heavier particle, which will move outside?
the lighter particle.
Yeah. So lighter particle will be thrown away far,
Yes, sir.
right? Because it's lighter. Heavier will be rotating there,
Yes, sir.
right?
Yes, sir.
Okay. Fine. Very good. That's what I was about to talk. Okay, then we'll see you in next class. Kindly everyone join on time next time.
Sir.
Yeah. Yes.
Sir, I posted one doubt in the group, sir.
Okay. I'll solve it. What was the question? Let me check.
1 minute, sir.
Let me check.
It's not from this chapter.
It doesn't matter.
Okay. Okay, sir.
Oh, there's a question. Okay, surface tension question. Okay.
Yes, sir.
So by the surface tension sigma, what makes a plane soap film? On a soap film, we place on a loop of rubber, band of rotate length, total length is L, the cross-sectional area of the rubber band is S, and its Young's modulus of elasticity is E. While the film inside the loop is pierced, the rubber loop requires a circular shape. Find the tension in the rubber loop. Okay. So what doubt you have in this one? We can't be solving. Yeah.
Sir, I didn't understand the question on sir.
Oh, you didn't understand the question itself?
Yes, sir.
Okay, shall I give you explanation? You will try again?
Yes, sir.
Okay. See, as usual, I'll read that again. A soap has surface tension sigma. The soap surface tension is given as sigma. So we make a plane soap film. On the soap film we place on the top of the rubber. So in short, they are placing on the top of the rubber band. The length of the rubber band is L. And cross section is given is S. So they are given in terms of variables. Young modulus is E. Now film inside the loop is pierced, means it is like made a hole. So the rubber band loop acquires a circular shape. So if I draw here, oh, it's not connected. Wait. 1 second. Okay, let me stop this.